Good morning, students. Welcome to the last session of this lesson, motion, and hope we'll be getting together again in school. We have started motion in the last week. I'll just recapitulate everything for you, and then last topic was left in this lesson. So with motion, the first thing we had to talk about uniform and non-uniform motion. Now uniform and non-uniform motion, if we talk in the terms of graph, if this is time and this is velocity, so if such graph will make, then such motion can be called as uniform motion, because a motion in which equal distance is covered in equal interval of time is called as uniform motion. If we see this type of graph where the object is moving like this, in this you can see equal distance is not covered in equal interval of time. That's why this is non-uniform motion. After talking about uniform and non-uniform motion, there were equations of motion in which a graph was told. The graph was like this: A to B. X-axis was explaining time, Y-axis velocity. This is origin, initial velocity. Certain suppositions we did in this way, and we named them as C, D and E. So we have started the equation from BC. BC is equal to BD plus DC. This BC is final velocity, that is V, and this DC is initial velocity U. So BD is equal to V minus U. This we got. Then we have introduced the definition of acceleration. Acceleration is change in velocity, rate of change of velocity. So acceleration here, rate of change of velocity means final velocity minus initial velocity. Here final velocity is BC and initial velocity is DC, and time here is OC. So now here BC minus DC, this BC, and if you minus DC you will get BD. So here you will get A is equal to BD upon this OC is T. So here you are getting BD is equal to AT. So this is, you can name B. Now if you compare A and B, you can see left hand side is same. So right hand side also will be same, and you will be getting V minus U is equal to AT, and finally V is equal to U plus AT. This is first equation of motion. This is also called as velocity time relation. Now moving on second equation. The first is velocity time relation. Second equation is position time relation. So position starts with S. In this we are considering this trapezium as O, A, B, C. So trapezium OABC, this is made up of two geometrical figures. The first is a rectangle OADC, and one is a triangle ABD. Applying the formulas of areas, area of rectangle length into breadth, length, breadth. So OA into OC plus area of triangle half, base AD, height BD. Putting the values, OA is U, OC is T, plus half AD. AD is parallel to OC, that means T. And here this is important, the value of BD here you have to take from this B equation, that is AT. So you are getting an equation S is equal to UT plus half AT square. This is the second equation of motion called as position time relation. First was velocity time relation, second is position time relation, and the third equation here we are getting velocity position relation. So this is also position. Here we are considering trapezium OABC. Here area of trapezium. Area of trapezium is half sum of parallel sides into height. So half sum of parallel side. This is a parallel side and this is a parallel side. So this parallel side is BC plus OA and height is OC. Area of trapezium. Putting the values here, half BC is V plus OA is U, V plus U, and here you have to keep in mind, as you kept in mind here, the value of BD you have put from here. This OC you are getting T, and this value of T you have to put from the first equation. So you will get half V plus U, V minus U upon A. So now S is equal to V square minus U square upon 2A. So finally we can write twice AS is equal to V square minus U square. This is third equation of motion. In this way we had to talk about three equations. Now the topic which was left was uniform circular motion, the last topic of this lesson. Uniform circular motion. For this I want to give you some examples. Uniform circular motion, some examples are greatly easy. For example, have you seen any satellite taking round of Earth? They are taking round in a particular orbit. One more easy example, have you seen Formula 1 race where the bikers are racing on certain tracks? So when they are taking turn, have you ever noticed that they are taking turn from the inner circle, because they cannot reduce the speed? If they will reduce the speed, they will lag behind. That's why with the same speed they continue, but they are stick to this inner circle, because this inner circle, on this inner, by sticking to the inner circle, they are acted by centripetal force. The force which is center seeking is called as centripetal force. But unfortunately, if something happens with the biker, then you have seen the biker goes straight with the bike and a great accident takes place. Why it happens? Because that centripetal force was not able to hold, and that converts into centrifugal force, which is taking it away from the center. One more example is when farmers are saving their crops in the farm, many times they are using this. They are making certain apparatus, as they are taking 2 threads, leather strings, long leather strings like this, and they are tying a piece of leather here at the center, and in that they are putting a stone, and then they hold these two and rotate like this, and wherever they find that predators are destroying the crops, in that direction they just leave one of the string. So as they were continuously rotating the string continuously, and if one end of string is left, the stone goes in the straight direction, tangent. This is uniform circular motion. There are some sports also in which you can see to throw a stone. But now coming on the formula, uniform circular motion, the formula is very easy. That is, speed is equal to distance upon time. This was the first formula we have seen. The same is the formula. The only change here is this distance is 2 pi r, because the distance is here in circular form. That's why the formula is 2 pi r. So now v is equal to 2 pi r upon t. This is meter per second. Okay. Here you can calculate various problems. For example, you may be asked to calculate the speed of hands in the watch, seconds hand, a minute hand, or hour hand. Then maybe you are asked to calculate the speed of an athlete who is running on a circular track, or directly you can be asked the speed of a satellite also. So this is uniform circular motion, and this is all about the topic motion, my dear students. So now holiday homework, I just want to say that the NCERT exercise you can solve in the holidays, and I wish, and you all, my dear innocent students, the innocent children, you all pray to God that we will be back to school very soon to enjoy edutainment. Okay, so this is all about. I am proudly saying that I am Professor Gaurav, a proud Edifian who is dealing with you. And enjoy your holidays and do your homework. Bye.